This resource is the second in a multi-part series that considers a number of topics in trigonometry. Part 1 looks at radians, defining this alternate method for measuring angles, and providing methods for converting back and forth between degrees and radians. Part 2 focuses on right triangle trigonometry, looking at the 6 trigonometric ratios. It also looks at the identities that define the other ratios in terms of sine and cosine. Part 3 explores the connections between trigonometry and the Cartesian plane. Part 4 considers the inverse trigonometric functions, used for finding angles when the ratios are known. This resource will focus on right triangle trigonometry, which relates the measures of angles in a right triangle and the lengths of the sides. The first step in doing so is to be able to identify the sides effectively. The first side is the hypotenuse, which is the longest side of the triangle. It is across from the right angle. The other sides of the right triangle are named relative to a particular angle. The opposite side is across from the angle, and the adjacent side is next to the angle. Another way to think about the adjacent side is that it is one of the sides that form the angle. We will now consider the 6 trigonometric ratios that can be formed using these sides. The first ratio is sine, which is abbreviated SIN. This is the ratio of the length of the opposite side to the length of the hypotenuse. Cosine, abbreviated COS, is the ratio of the length of the adjacent side to the length of the hypotenuse. Tangent, abbreviated TAN, is the ratio of the length of the opposite side to the length of the adjacent side. These ratios are the 3 primary trigonometric functions. Scientific and graphing calculators have buttons to find these values for a given angle measure. However, there are 3 other trigonometric ratios as follows. Secant, abbreviated SEC, is the ratio of the length of the hypotenuse to the length of the adjacent side. Cosecant, abbreviated CSC, is the ratio of the length of the hypotenuse to the length of the opposite side. Cotangent, abbreviated COT, is the ratio of the length of the adjacent side to the length of the opposite side. Let's take a look at an example. Suppose we have triangle PAL with given lengths of 12 and 5. Wait, what? We need all 3 lengths to form all of our ratios. Luckily, we can find the missing length somewhat easily using an old friend, the Pythagorean theorem, a squared plus b squared equals c squared. Since we are missing the length of the hypotenuse, we put the x in for c. We have 12 squared plus 5 squared equals x squared. Squaring our numbers, we have 144 plus 25 equals x squared. Combining, we have 169 equals x squared. To find x, we take the square root. So x, the length of the hypotenuse, is 13. Now we can find our trigonometric ratios. First, let's consider angle P. The length of the side opposite P is 5, and the length of the hypotenuse is 13. So the sine of angle P is 5 over 13. The length of the adjacent side to angle P is 12. Although the side with length 13 is technically also adjacent to angle P, it is labeled with the special name hypotenuse. So the cosine of angle P is 12 over 13. The tangent of angle P is the opposite over the adjacent, so 5 over 12. The secant, formed by the hypotenuse over the adjacent, is 13 over 12. The cosecant, hypotenuse over opposite, is 13 over 5. The cotangent has the adjacent over the opposite, so it is 12 over 5. But what happens if we consider angle L instead? If we look from angle L, the length of the opposite side is 12, while the length of the adjacent side is 5. So the sine of angle L, opposite over hypotenuse, would be 12 over 13. Cosine, formed by adjacent over hypotenuse, is 5 over 13. Tangent, opposite over adjacent, is 12 over 5. Secant, hypotenuse over adjacent, is 13 over 5. Cosecant, hypotenuse over opposite, is 13 over 12. Cotangent, adjacent over opposite, would be 5 over 12. If we look at some of the ratios, we notice something. Secant is the same thing as cosine, just flipped over. Same with sine and cosecant, and with tangent and cotangent. These are actually identities, which means that those relationships always hold, that secant is the reciprocal of cosine, cosecant the reciprocal of sine, and cotangent the reciprocal of tangent. There is one more ratio that is often useful. Tangent can also be defined as the ratio of sine to cosine. When we have the ratios for sine and cosine, we only need to use the numerators. This is because the numerator of sine is the opposite, and the numerator of cosine is the adjacent. Remember, the original definition for tangent was opposite over adjacent. Let's take a look at an example. Suppose we know that the sine of angle theta is 7 over 25, and the cosine of angle theta is 24 over 25. We need to find the other trigonometric functions. Secant is the reciprocal of cosine, so we flip the fraction for cosine to find secant. Secant of angle theta is therefore 25 over 24. Cosecant is the reciprocal of sine, so we have 25 over 7. Tangent equals the sine over the cosine, or more specifically, the numerator of sine over the numerator of cosine. Therefore, tangent of theta is 7 over 24. Finally, cotangent is the reciprocal of tangent, so cotangent of theta would be 24 over 7.